Hey everybody, I just wanted to spend a little bit of time talking to you about nuclear chemistry. Let's first address the basics of nuclear chem. And just so you know, nuclear chemistry is mainly usually called radioactivity. If it's something that is occurring in nature, uh, you'll find that things break down with a lot of patterns. And also, where chemistry is a lot of time concerned with the electrons in the outer shell, radioactivity or nuclear chemistry is talking about how protons and neutrons break down in the nucleus of an atom, hence nuclear chemistry, and the energy transfers that happen because the nucleus is doing stuff. And so it really is an interesting little part of chemistry and physics. Excuse me. And this is one of the ways that really chemistry and physics are related, because nuclear chem can be we can talk about the chemistry, how matter is changed this way. We can also talk about nuclear physics. We could talk about the energy transfers and the forces and everything that's being held together. But all of these topics kind of interrelate and overlap when we're talking about chemistry and physics. Regardless, let's talk a little bit about the basics here. There are going to be three different types of natural radioactivity. I think Rutherford was the one that came up with these things, or he didn't come up with radioactivity, he came up with the names of the radioactivity. And so we're going to start with alpha radiation, and that's the lowercase Greek letter alpha. It also looks like a little Jesus fish there. And alpha radiation is the heaviest of all of the radiations. It's actually a helium nucleus, okay? And so when we try to write the symbol for this, we put the mass up here, we put the number of protons down here, and this is the number, and so that's what it is. And so typically we don't write the helium nucleus. Typically we would write an alpha particle for 2. And so that gives us the context with which we are using this particle. If we mean a helium nucleus, we would write this. If we're talking about radioactivity or radioactive decay, we're going to use the alpha particle. Okay. And because it's so heavy, and I know that typically in chemistry we think of heavy things not being helium. Typically we think of things being way down the periodic table, but compared to the other forms of radioactivity, this is by far the heaviest type. Because it's so heavy, it's easily absorbed and easily protected against by things. Okay, I think just like a sheet of paper, 10 sheets of paper can protect whatever you're trying to protect from alpha radiation. Okay, but beta radiation is a little bit smaller. Okay, it's light, as we can see here, and this is just an electron. And again, this is our context. For an electron, we would always do this, okay, and we would put a 1- charge here, okay, but that's not how we're going to indicate beta radiation. Okay, we're going to put a beta here, Greek letter beta, second letter of the alphabet. It's kind of a capital B, even though it's lowercase. It looks like a capital normal B with a tail on it. Okay, and then we're going to put a 0 up here because an electron has no mass, and then we're going to put a -1 down here to indicate its quote unquote atomic number. Okay, and electrons can penetrate. Okay, they have because they're higher energy and lighter, they're able to penetrate thicker pieces of material. The last type of electromagnetic radiation is gamma radiation. Okay, I'm sorry, the last type of nuclear radioactivity is gamma radiation, and this is electromagnetic radiation. Okay, when we talk about light, and there's 7 areas on the electromagnetic spectrum, gamma is one of them. It's very high energy. Okay, gamma is the third letter of the Greek alphabet. When I write it, I kind of write it like this, maybe like an alpha facing down, and then there's no anything on this. Okay, so it's going to be its symbol's going to look like that. Okay, and so these are the worst sort of particles. Okay, these particles are the ones that are the most penetrative. They can go the deepest into things. You need lots of lead in order to protect yourself from these sorts of things. Okay, so we're going to, so in terms of energy, and this is kind of where Rutherford came up with these names. Alpha was the first one, the heaviest. Beta was the second heaviest. And then a second guy came along and discovered gamma radiation and kept the pattern alive. And so that's where gamma radiation comes from. So if I were you, I would take a minute and look down here, copy down this information here, definitely, okay, and then kind of know what this is, okay, so that you have some idea of what's going on. So there you have it. That's some basics of nuclear chemistry. Have a great day.